Good afternoon, students. Myself, Munshi Rashidul Islam, Assistant Professor, Department of Mechanical Engineering, JIS College of Engineering. Now, today we have discussed about the point, and that is the method of virtual work. So, first of all, we have some point that is actually in the outline of this presentation, and that is first the introduction part, then principle of virtual work application, and the proof of principle of virtual work, and some example of principles of virtual work. Now the method of virtual work. So as we know that the virtual work is actually a method or actually a phenomena that the work done can be generated virtually when the small distance can be considered and mainly it is done in the structure analysis when the structures can be considered in for the virtual perspective. Now the method of virtual work, first one is previous methods, that means free body diagram and summation of total force F, and also the summation of moments are generally employed for a body whose equilibrium position is known or specified. Now for the second is for problems in which the bodies are composed of interconnected members and that can move relative to each other. And now various equilibrium configurations are also possible and must be examined. Now the previous method can still be used but not the direct or convenient. And now method of virtual work is suitable for analysis of multi-linked structures, that means pin jointed members with changed configuration. Now also the effective when the simple relation can be found among the displacement of the points of application and various forces which are involved and based on the concept of work done by a force. So work done by a force. So if the force is applied on a angle, so that's why the U is equal to work done by the component of the force in the direction of the displacement time, and now the U is equal to F cos alpha del S, or U is equal to F del X cos alpha. Since the same results are obtained irrespective of the direction in which we resolve the vectors and when the work is a scalar quantity. Now plus U is actually the force and displacement in same direction, and minus U is equal to the force and displacement in opposite direction. So U is equal to F cos alpha and del S, and that is also equal to the minus F cos alpha cos theta del S. Now generalized definition of work. So work done by F during displacement dr, which is shown in the figure. So del U is equal to F into dr. So du is equal to F into ds into cos alpha. And now expression F and dr in terms of their rectangular components. So du is equal to Ifx plus jfy plus kfz into I into dx plus j dy plus k dz. So total work done by F from A1 to A2. So U is equal to F into dr, that also equal to summation of fx dx plus summation of fy dy plus summation of fz dz. So total U is equal to integration f cos alpha into ds. Here if this figure the now f cos alpha is directly or indirectly applied on a point where the total force is acting with some certain angle. Now work done by a force. The forces which do no work, that means force applied to fixed point, so ds is equal to 0. Force acting in a drain normal to the displacement, that means cos alpha is equal to 0. Reaction at a frictionless pin due to rotation of the body about the pin. And now reaction at a frictionless surface due to motion of a body along with the system of the surface finish, and that can be used in some certain angle. And now the weight of the body with CG moving horizontally, friction force on a wheel moving without slipping, sum of the work done by several forces may be 0. That means the body is connected in such a way that the frictionless pin can be used. The body is connected by an inextensible cord, and now third point is the internal force holding together that parts a rigid body also be connected. Now work done by a couple. So small rotation about a rigid body, so translation to AB, translation to A dash B dash. So work done by F during displacement A dash will be equal and opposite to work done by minus F during BB, and total work done is 0. So rotation A dash about B dash to A. So work done by F during displacement AA. So U is equal to F into dr A by B. That is equal to F into B into d theta. Since M is equal to FB, so du is equal to M into d theta, where plus M is actually the same, plus M has same sense as theta, and minus M has same sense with opposite theta angle. So the total work done by a couple during a finite rotation in its plane, so U is equal to integration M into d theta. Now dimensions and unit of work. So force into distance, that is equal to joule, and that also equal to the Newton meter. Work done by a force of 1 Newton moving through a distance of 1 meter in the direction of the force. Dimensions of work of a force and moment of a force are same, though they are entirely different physical quantities. Now work is a scalar given by dot product, involves product of the force and the distance, both measured along the same line. And obviously the moment is a vector given by the cross product, involves the product of a force and distance measured at right angles to the force. The unit of work, that means the joule, and the unit of moment, that also the Newton meter. Now virtual displacement. The virtual displacement is not experienced but only measured to exist, so that the various possible equilibrium conditions may be compared to determine the correct one. So imagine the small virtual displacement of particle dr, which is acted upon by several forces. So suppose U is equal to F1 to 2, and the actually some error also be there in virtual work final equation, because some misprinting also be there. So the actual corresponding virtual work that will be based on some equilibrium portions of a particle, and it may be depends on some total work done, and also the particle due to the virtual displacement dr. So del U is equal to F1 into dr plus F2 into dr plus F3 into dr plus dot 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 up to summation of F into dr. Now expressing summation F is in terms of scalar sums and dr in terms of its component virtual displacement in the virtual equilibrium cases. So del U is equal to summation of F into dr, and that also equal to I summation of Fx plus j summation of Fy plus k summation of Fz into I dx plus j dy plus k dz. So that also equal to summation of Fx into dx plus summation of Fy into dy plus summation of Fz into dz is equal to 0. So the sum is 0, since summation of F is equal to 0. So individually summation of Fx is equal to 0, summation of y is equal to 0, and summation of Fz is equal to 0. Now the alternative statement of the equilibrium, that means del U is equal to 0. Now this condition is 0 virtual work for equilibrium in both necessary and sufficient, since we can apply it to the three mutually perpendicular directions and the three equilibrium conditions. Now the principle of virtual work. If a particle is in equilibrium, the total virtual work of a force that will acting on the particle is 0 for any virtual displacement. So if I consider a rigid body is in equilibrium, then the total virtual work of external forces which are acting in the body is 0, and the virtual displacement of the body. So if the system of a concerned rigid body remains connected during the virtual displacement, now the work of the external force can be considered, and since the work done by the force with equal and opposite and also the collinear can be considered here. Now in these cases the equilibrium of a rigid body, so we know that the total virtual work done on the entire rigid body, that means the work done on each particle of the body is equal. So that's why the weight of the body is negligible. So work done P is equal to Pa into theta, and work done by R is equal to plus RB into theta. So principle of virtual work, du is equal to 0. So PA minus theta, PA into theta plus RB minus RB into theta is equal to 0. So PA minus RB is equal to 0. So the equation of the moment conditions at O. So nothing gained by the using of principle of virtual work for a single digit body. So that's now for the today's class. Now the next class we can discuss with a new and the new analysis of virtual work problem and can discuss in this class. Thank you.